Question 10.a. A rock of mass 2 kg is projected horizontally with an initial horizontal velocity of 5 meter per second from the top of a 5-meter high building as shown below. What is the kinetic energy of the rock just before it hits the ground? So here in this question you have a rock of mass m equals 2 kg, which is projected horizontally with an initial velocity, which we will write as Vx0 of 5 meter per second. Vx0 because this is the horizontal component of velocity, that is along the x-axis. The height of the building I will write as h, which is equal to 5 meter. And we need to find kinetic energy of the rock just before it hits the ground. So I need to find what is the final kinetic energy, K final. So we can solve this problem using two different methods. One will be to use the law of conservation of energy, and the other one by determining the values of velocity and then calculating kinetic energy from the final velocity. We will discuss both methods in this video. So let us start with the law of conservation of energy. We know from the law of conservation of energy, total energy of an isolated system always remains constant. So if I take 2 points in motion, let's say this is my initial point, I will call it 1. And when the ball falls off the cliff, just before it hits the ground, let this be my final point, I will call it 2. According to law of conservation of energy, total energy at point 1 has to be equal to total energy at point 2. Now total mechanical energy at any given point can be written as sum of its kinetic plus potential energy. So E1 I will write as the sum of kinetic energy K1 plus potential energy U1, and total mechanical energy at point 2 will be K2 plus U2. K1 is the kinetic energy at point 1, and since the rock is fired with a velocity V equals 5 meter per second, I will write kinetic energy at point 1 to be equal to half mvx0 squared plus potential energy at this point will be mgh because the rock is raised at a height h above the ground equals kinetic energy at point 2 is the final kinetic energy. That is what we need to find here. So I will write this as K2. Potential energy at the bottom will be 0 because the height h here is 0. So this will become 0. So I get K2 to be equal to half mvx0 squared plus mgh. Now you can substitute to calculate the value of kinetic energy. Half times m is 2, vx0 is 5 squared plus 2 times g, which is 9.81, and h is the height, which is 5. And when you solve this, you get kinetic energy just before it hits the ground to be equal to 123.1 joule. Now we are going to solve the problem by using the second method, where we will determine the final values of velocity and then calculate the kinetic energy. Here in the question, the rock is projected horizontally, and in case of a horizontally launched projectile, the initial y velocity is equal to 0 because my initial velocity is only horizontal, which is along the x-axis. So when the rock is projected with an initial velocity from the top of the building, it follows a parabolic path and falls on the ground. We're going to find the value of its final velocity to calculate the kinetic energy at the bottom just before it hits the ground. So to find the magnitude of final velocity, we need to know what are the x and y component of this velocity. Now for projectile motion, the x component of velocity remains constant throughout the motion as there is no acceleration along the x-axis. So whatever initial velocity we had along the x direction, that will be the same as my final x velocity. So final x velocity will be the same as initial, which is 5 meter per second. Now we will solve for final y component. Y component of velocity we can find using equation of motion. I have the initial y velocity, which is 0. We know the acceleration here is acceleration due to gravity g, which is negative 9.81 meter per second squared. And the height that the rock is falling is 5 meter. And since it is falling down, the displacement delta y is negative. So my distance covered will be negative h, which is equal to negative 5 meter. So we will use the fifth equation of motion to calculate the final velocity along the y-axis. I will write v final squared equals v initial squared plus 2a delta y. Now substitute. V initial squared is 0 because V initial along y-axis is 0, plus 2 times A is G, which is negative 9.81. Delta Y is negative H, which is negative 5. And when you solve this, you get Vy to be equal to square root 2 times 9.81 times 5. Minus minus will become plus. And that gives me the final value of velocity along the y-axis to be equal to 9.9 meter per second. Once I have the final x and y components of velocity, I can find the final magnitude of velocity using Pythagorean theorem. So I get v final to be equal to square root vx squared plus vy squared, which is equal to square root 5 squared plus 9.9 squared. That will give me 11.1 meter per second. This is the velocity of the rock at the bottom just before it hits the ground. We can find the kinetic energy by using the rule K equals half mv squared. So since we are finding the final kinetic energy, I will write v final squared. That gives me half. Mass of the rock is 2 kilogram. Velocity is 11.1 squared. And that gives me kinetic energy to be equal to 123.1 Joule. So you get the same answer using both the methods. Now part B of the question. A rock of mass m is projected horizontally with an initial velocity v from the top of a building of height h as shown below. Write an expression for kinetic energy of the rock just before it hits the ground. So here in this question, we have to write an expression for kinetic energy. And as discussed before, you can solve this by either using law of conservation of energy or by determining the values of velocity at the bottom. I'm going to use the law of conservation of energy here. So we know from law of conservation of energy, total energy for any isolated system remains constant. That means if I take 2 points in motion, let this be my initial point, which I will call as 1. And when the rock falls at the bottom, this region before it hits the ground, let me call it 2. So from the law of conservation of energy, total mechanical energy at 1 has to be equal to total mechanical energy at 2. Now mechanical energy can be given as sum of kinetic plus potential energy. So E1 I will write as kinetic energy at 1 plus potential energy at 1 equals E2, which is kinetic energy at 2 plus potential energy at 2. Kinetic energy at position 1 will be half mv squared, and potential energy will be the gravitational potential energy, which is mgh. Kinetic energy at position 2 is what we need to find. I will write it as K2. And U2 is 0 because at the bottom the height h is 0. So we write this as 0. So you get K2 to be equal to half mv squared plus mgh, which will give me, if we take m as common outside, v squared by 2. In place of small h, I can write capital H, which is the height of the building, plus g times h. So this is the expression for kinetic energy of the rock just before it hits the ground.